6-3, solving systems of equations using elimination. So our objective is to solve systems by adding or subtracting to eliminate a variable. And our essential understanding is that there's more than one way to solve a system of equations. Some systems are written in a way that makes eliminating a variable a good method to use. So in the previous section, we looked at solving a system with substitution. Okay? This time, we are going to use the addition and subtraction properties of equality, because if A is equal to B and C is equal to D, okay, we have two equations, both of which are true. So because A is equal to B and C is equal to D, let's get this. Let's put this over here. C is equal to D. Remember, I am allowed to do anything to an equation as long as I do the same thing to both sides. Well, if I wanted to, I could add D to both sides. Okay? Or, because D and C are equal, I could add C to both sides as well. Or C to the left side and D to the right side. That's what this says right here, that A plus C is equal to B plus D. All right? Or minus. And an example is 5 plus 1 is 6. So 5 plus 1 equals 6. 3 plus 4 equals 7. If I were to add these two equations together, or 5 plus, right, if I were to add 3 plus 4 to 5 plus 1, I would still get 6 plus 7. Or even better, if I add these two equations together, I get 8 plus 5 is equal to 13. And 8 and 5 is actually 13. Okay, so no matter which way I look at these, I am allowed to do things like this. I am allowed to add the same thing to both sides of an equation, regardless if that same thing is 3 plus 4 or 7. Okay? In the elimination method, we are going to use these properties in order to eliminate a variable in the system. With substitution, my goal was to get an equation with only one letter by replacing one letter for a different letter. In the elimination method, because when I look at these coefficients right here, 2, 5, 6, negative 5, none of these variables are easy to get to be just the letter, right? Just the variable. None of them are easy to get alone. But what I do notice is that these two are opposite of each other. So, again, from the properties I just looked at, I am allowed to add whatever I want to both sides of the equations as long as that thing is equal, right? As long as I do the same thing to the left as I do to the right. Well, I could subtract 9 from both sides of this equation, which is something I'm allowed to do. But subtracting 9 from this left side here doesn't really help me. So instead of subtracting 9, why don't I add 6x minus 5y? Because isn't that, according to this equation right here, the same thing as negative 9? It is. Now when I add these two equations together, watch what happens. I get 8x, and I get the y's to go away. And 8x is going to be equal now to 17 minus 9, which is 8. Okay? Now that the y's went away, I can solve this equation and get that x is equal to 1. That's great. Okay? Again, just like last time, the goal here to solve the system, to find the solution, is to find the point where these two lines intersect. So now that I have x, I can plug it into either the top or the bottom. Pick whichever one looks easier. Let's pick the top one because less negatives. So 2 times 1 plus 5y is going to be 17, which gives me 2 plus 5y is 17. Subtract the 2 from both sides, and I get that 5y is equal to 15, and y is equal to 3. So the point where these two lines intersect is 1, 3. So my solution is 1, 3. Let's look at some guided problems. Again, what do I notice? The y's are opposite to each other. All I have to do is add these two equations together. And I get 8x, the y's cancel, is equal to positive 16. Divide out the 8, and I get that x is equal to 2. Plug it back in. Let's plug it into the bottom one because there are less negatives there. So 3 times 2, which is x, plus 6y is equal to 48. So 6 plus 6y, 48. Subtract the 6 from both sides. Gives me 42. Divide by 6 to give me that y is equal to 7. Right? And my solution then is 2 comma 7. For the left one, again, add these together. The x's go away. Negative 7y is equal to 14. Divide out the negative 7, and we get that y is negative 2. Plug it back into either one. Let's use the bottom one again. Looks a little simpler. 3 times, oops, don't plug it in for x because it is y. 3x minus 4 times negative 2 is equal to 5. Okay, so that's 3x plus 8. Get a little more room. Subtract the 8 from both sides. 3x is equal to negative 3. And x is equal to negative 1, which makes the point where these two lines intersect negative 1, comma, negative 2. Let's try a word problem. Okay? So a theater club, again, I forgot to include the choices there, so it's not multiple choice anymore. The theater club sells a total of 101 tickets to its first play. A student ticket costs $1. An adult ticket costs $2.50. Total ticket sales are $164. How many student tickets were sold? So let's first we got two variables. We got student ticket and adult, or how many student tickets and how many adult tickets. So my goal here is to solve for the number of student tickets. So we have that x plus y, student tickets plus adult tickets, is 101, and that 2.5 times x plus uh, student tickets $1 plus y is going to be equal to 164. Okay. So now we have a problem. If we add these two equations together, neither one of the variables is going to go away. But because these two are the same, I could subtract. So I can take all these terms and multiply by negative 1 and then add them together. Okay? So now I get negative 1.5x. The y's go away, and it's equal to negative 63. Divide out negative 1.5, and I get that x is equal to 42. Okay? That is the number of adult tickets. I want the student tickets. We could have, if we wanted to, solve this with substitution. But I wanted to show you that we can put these together even though they're not opposite. Okay. So now again, plug this back in, that 42 plus x is 101. Subtract 42 from both sides. Sorry, not x, y. Subtract 42 from both sides, and we get that y is equal to 59. Okay. Let's look at another one. Washing 2 cars and 3 trucks takes 130 minutes. Washing 2 cars and 5 trucks takes 190 minutes. So 2 cars plus 3 trucks is 130 minutes. 2 cars plus 5 trucks is 190 minutes. Okay? So now, again, I notice that these two coefficients are the same, but they are both positive. So what I have to do is I want to multiply this whole thing by negative 1, which gives me 2x plus 3y is 130. And notice what I'm able to do here is now, just like the previous problem, I'm able to make this equation a similar equation. As long as I do the same thing to both sides, I multiplied the left side by negative 1, I multiplied the right side by negative 1. As long as I do the same thing to both sides, to every term, my resulting equation, this one right here, is still equivalent. Now when I combine these terms, I get the x's to go away. I get negative 2y is equal to negative 60. Divide out the negative 2, y is equal to 30. Plug it back in. That 2x plus 3 times 30 is 130. 2x plus 90. Subtract that out. And x is 20. Okay? So it takes 20 minutes to wash a car, 30 minutes to wash the truck. Okay? We were able to solve this with elimination. Now, this particular system was not a good choice for substitution, whereas this one up here I could have because I have 3 places where x or y is by itself. So in problems 1 or 2, the variable is eliminated because the sum or difference of the coefficients is 0. From the multiplication property of equality, you know that you can multiply each side of an equation to get a new equation that is equivalent, which is kind of what we did right here when we multiplied everything by negative 1. So you can multiply each side of an equation to get a new equation that is equivalent to the original. That is, a plus b is equal to c is equivalent to a d times a plus b is equal to d times c. I can multiply this number d by the left side and the right side. So dA plus dB is equal to dC. Since this is true, you can eliminate a variable by adding or subtracting if you first multiply an equation by an appropriate number. You can prove that the results are the same simply by substituting the values for the variables in the original equations to show that the equations are true. So what did all that mean? Basically, it means if you have a system where you cannot just add the two systems together, or the two equations together, and get a variable to go away, multiply it by something so you can get one of the variables to go away. Look at this problem right here. So we have negative 2x plus 15y is equal to negative 32. 7x minus 5y is equal to 17. Just adding these together does me no good. But if I look and try to find the easiest way to multiply something to make one of the letters go away, I can see that if I take the bottom of equation and multiply everything by 5, I will get a system, an equivalent system, x plus 15y is equal to negative 32. And now I have, sorry, I'm not going to multiply by 5. Multiply by 3. 5 times 5 is 25. 5 times 3 is 15. Okay? That would give me 21x minus 15y is equal to 17 times 3 is 51. Yes, 51. Okay. Now when I add these two equations together, I get 19x, the y's cancel, is equal to 19. Yeah, how convenient. Divide out the 19, and x is equal to 1. Of course, pick an equation. Either equation, plug back in 1. Bottom one looks a little bit easier. So 7 times x, which is 1, minus 5y is equal to 17. So that's 7 minus 5y. Subtract the 7 from both sides. Negative 5y is equal to 10. Divide out the negative 5, and I get that y is equal to negative 2. So my answer is 1 comma negative 2. And 1 comma negative 2 is the point where these two lines intersect. I can use the multiplication of probability to change this system to an equation. Oh, first of all, before we look at that one, I didn't have to multiply the bottom equation by 3 to make the y's cancel. I could have thought of a way to multiply the top one and the bottom one by something to make the x's cancel. Okay, I could multiply the top by 7 and the bottom by 2, and I would have a negative 14 and a positive 14x. But multiplying the bottom one by just 3 was simpler. So let's try to find the simplest way that I can make this system negative 5x minus 2y is equal to 6. 3x plus 6y is equal to 6. Adding these together doesn't help. The 3 and the 5 I see are opposite terms. That's nice. The 2 and the 6, those are opposite terms. That's nice. Can't think of anything that will make a 5 into a 3. I would have to multiply both. But if I multiply the top one by 3, yes, 3, the y's will cancel. So my new system becomes negative 15x minus 6y is equal to. Now, the biggest mistake people make is don't forget to not only multiply the left side of the equation by 3, but you have to multiply the right side as well. So that is now 18. 3x plus 6y is equal to 6. Adding these together gives me a negative 12x is equal to 24. Divide negative 12, and we have that x is equal to negative 2. Pick one, plug it back in, and it could be any of these equations. This one, this new one, this old one, whichever one you want. Let's use the bottom one. That one looks not too bad. So 3 times negative 2 for x plus 6y, 6y, ugly 6, is equal to 6. So that's negative 6 plus 6y is equal to 6. Add it to both sides. 6y is equal to 12. Y is equal to 2. So my answer is x comma y. Okay, negative 2 comma 2. So for this next one, just looking at this, 3x plus 2y is equal to 1. 4x plus 3y is equal to negative 2. Just looking at this, I cannot see anything that I can multiply to get me one equation equal to the other one. I'm going to have to do something twice. So I could multiply the top equation by 4, the bottom equation by 3 to get or negative 3 to get a positive 12 and a negative 12. But I usually like to pick the numbers that are the smallest numbers. So let's multiply the top equation by 3. And the bottom equation, I could multiply by 2 and subtract, but I like to always add my two equations together. Prevents mistakes. So I like to multiply by negative 2. My equivalent system becomes 9x plus 6y is equal to, don't forget to multiply, 3. Negative 8x minus 6y is equal to a positive 4. Now when I add these together, 9 and the 8, give me x, y's cancel, 7. Nice. All done. Pick one to replace the 7. And it can be any one you want. One of these two new ones, one of these two old ones. Again, go for the one that has the smallest numbers, least amount of negatives. So I'm looking at the top one. So that's 3 times 7 plus 2y is equal to 1. 21 plus 2y is equal to 1. Subtract 21 from both sides gives me 2y is equal to negative 20. So y is equal to negative 2. My answer, x comma y, which is the place where those two lines, these two lines intersect. Okay? How can we change these? Solve the system, show that the original system is a solution because we can plug the equation back in. Okay, so basically we're just going to solve this. 4x plus 3y is equal to negative 19. 3x minus 2y is equal to negative 10. And again, I like to pick the numbers that are going to work the best. I see a positive 3 and a negative 2, which means I don't need to worry about a negative sign, and I'm going to multiply the top by 2 and the bottom by 3. I could multiply the top by 3 and the bottom by negative 4, but those are bigger numbers, and one of them's negative, so that seems a little bit harder to me. 8x plus 6y is equal to negative 38. 9x minus 6y is going to be equal to negative 30. Adding these together gives me 17x is equal to negative 68. Divide out the 17. Should go evenly. X is going to be equal to negative 4. Again, pick the easiest one. I'm going to go with the bottom one. Even though it has two negatives instead of 1, numbers are a little smaller. I like that. 3 times negative 4, which is x, minus 2y is equal to negative 10. Let's get a little more room. So that's negative 12 minus 2y is equal to negative 10. Adding 12 to both sides equals 2. Y is equal to negative 1, which makes my answer negative 4 comma negative 1. Recall that if you get a false statement as you solve the system has no solutions. If you get an identity, both sides the same, then the system has infinitely many solutions. So how many solutions does the system have? Well, first, in order to solve it, I'm going to take the top one, and I'm going to multiply this whole bottom one by negative 2. And then watch what happens. We get negative 2x minus 6y is equal to negative 18. Adding these together gives me an identity that 0 is equal to 0. That means there are infinitely many solutions. These two equations happen to be exactly the same. If I multiply by a positive 2, look, I have the same equation. They are the same line. They intersect everywhere because they're the same line. How many solutions does this have? Well, I can clearly see these two are the same, these two are the same, but these two are not the same. When I add these together, I would get 0 is equal to negative 5, which is no solution. Okay? So basically, what you should do when you are thinking about which way to solve a system, think about, can you eliminate a variable by adding or subtracting the given equations? That's usually easier. Okay, so if you have a situation that looks like this, back in the first one, usually the easiest thing to do is just to uh, add these two equations together. Multiply one of the equations by something. That's your next step, which is an equation that looks like this one. Try to multiply only one. If you can't multiply only one, then you're left with multiplying both of them, the top and the bottom one. Okay, so our lesson check. Solve each system. So this one, just add together. This one, multiply the top equation by a positive 2. And then this one, I would multiply the top equation by a positive 3, the bottom equation by a positive 2 to get these two to be positive 6 and negative 6. 4, if you add two equations in two variables and the sum of an equation and the sum is an equation in one variable, you are using elimination, right? And that's the point of elimination, is to get rid of one of the variables. Explain how the addition property of equality allows you to add equations, because you're adding the same stuff. You're adding something equal to something else. You're adding the same thing to both sides, okay? Because even though they don't look the same, even though it could be 4 plus 2x and 14, the middle thing, the equal sign, says these two are the same thing. So I could add this to that and this to that to get an equivalent expression. And how would you solve a system of equations using elimination? Get one of the variables to go away, right? And that was 6-3, solving systems using elimination.